we have another example. This time we're supposed to find resistance R1. Okay, so I'm going to write find. We have to find resistor R1. Okay, we're supposed to find current. I'm going to call this current Ix. Okay, this is my Ix. So I have to find current Ix. Okay, and basically we can also find later on total resistance. Okay, and in order to make this problem more interesting, we are going to find also power at each resistor, P1, P2, and P total. Okay, so now first we have to look at this circuit. Please notice that these two voltage sources are connected in parallel. Keep in mind, you can do this only when the voltage is theoretically the same. Okay, so in this case, voltage source 1 has 8 volts and voltage source 2 has also 8 volts. So theoretically, we can connect them together. Remember, we cannot connect two voltage sources in parallel if they have different voltages. Okay, but if they have the same voltage, we can connect them together. So, voltage across resistor R2. Voltage across resistor R2 is equal 8 volts. Okay, so what we can do in this case, we can find the current which goes through this resistor. So I can write that IR2 is equal simply my voltage V1 or V2, it doesn't matter because this is my voltage. I'm going to call this, let's say, V2 because it's closer to this resistor over R2. It doesn't matter which voltage you are going to use. As I said, they are connected in parallel. So I have V2 8 volts over R2, which is equal 4 kilo ohms. 8 volts divided by 4 kilo ohms is equal 2 milliamps. Okay, so this is my current which goes through this resistor R2. Okay, how it is supposed to be calculated on the calculator? Simply enter 8 divided by 4 exponent 3. This is equal. Okay, you will get this number, but I'm going to switch my calculator to scientific notation. And my answer is 2 milliamps. Okay, so this is exactly the same answer which I got over here. 2 milliamps. So I know that current 2 milliamps is going through this resistor. Okay, I know that the current, this is given, which comes from the voltage source V2 has value of what? 3 milliamps. So if 2 milliamps is going over here, okay, through this resistor R2, so the remaining one is going to be my Ix. So I can simply say that my Ix is equal I source 2, okay, this is my source current, okay, I source 2 minus IR2 is equal simply Ix. So this is equal 3 milliamps minus IR2, which is equal 2 milliamps. So this is equal 1 milliamp. So I found the current which will go through this connection. Okay. Next, you're supposed to realize that we have also another current which will go through the through the voltage source V1. Okay, so this current is going to occur also over here, right? So these two currents are going to meet together and will go through resistor R1. So I can say that R1 is equal I source 1 plus Ix. So this is equal 3 milliamps plus 1 milliamp. Okay, 3 milliamps from here plus Ix, which is 1 milliamp. So this is equal 4 milliamps. So I found current which goes through resistor R1. If I have current which goes through resistor R1 and I have voltage across this resistor, keep in mind that this resistor is in parallel with the voltage sources, okay, and this is basically voltage of 8 volts. So the voltage across resistor is equal 8 volts. So I'm going to write that R1 is equal, let me use V1 over IR1, where V1 is equal what? 8 volts divided by R1 divided by IR1, which is equal 4 milliamps. Okay, over here, 4 milliamps. So 8 volts divided by 4 milliamps is equal 2 kiloohms. Okay, for those of you who do not know how to use the calculator, I'm going to enter this calculation into the calculator. So I have 8 divided by 4 exponent 3 negative. This is equal 2 kiloohms. Okay, so this is value of my resistor R1. Now if I have R1 and I have R2, I can find R total. R total, okay, I'm going to calculate by using the product over the sum formula, okay, because I have just 2 resistors. So I have R1 times R2 over R1 plus R2. This is equal, R1 we said is equal 2 kiloohms times R2, which is equal 4 kiloohms, over 2 kiloohms plus 4 kiloohms. Okay, I'm going to use the calculator. Okay, so I have 2 exponent 3 times 4 exponent 3 equals, divided by, open parenthesis, 2 exponent 3 plus 4 exponent 3, close parenthesis, this is equal 1.33 kiloohms. Okay, so this is my total resistance, 1.33 kiloohms. Okay, so far we found Ix, we found R1, we found R total. Okay, so we can find also I total. Okay, I total we can find by simply dividing total voltage over total resistance. Okay, so we have total voltage is equal 8 volts. So let me just put V over R total. Okay, where V could be V1 over R total, or this is also can be V2 over R total. Why? Because they are the same and they are connected in parallel. So I'm going to simply write that this is 8 volts divided by 1.33 kiloohms. This is equal, I have 8 volts divided by 1.33 exponent 3. This is equal, we can say, 6 milliamps. Okay, so now let's take a look at the diagram. Please notice that we have current, right, which will be generated by this voltage source equals 3 milliamps, and we are going to have also 3 milliamps over here. So the total current is going to be simply the sum of these two currents. So I can say that I total is also equal I source 1 plus I source 2, right? So this is equal 3 milliamps plus 3 milliamps is equal 6 milliamps. So as you can see, we found the total current using two different ways and the answers are the same, so it means that so far we are okay with our calculations. So we found I total. Next we can find the powers. Okay, P1, okay, power at resistor R1, I'm going to find by using the formula, let's say V1 square over R1. Okay, so I have to find P1. V1 is given, so I have 8 volts to the second power over R1. We found R1, and R1 is equal 2 kilo ohms. So I have 2 kilo ohms. So now I have 8 square divided by 2 exponent 3. This is equal 32 milliwatts. 32 milliwatts. This is my power at resistor R1. Next I'm supposed to find power at resistor 2. So I'm going to write P2 is equal V2 square over R2. And again, I can use V1 or V2 because these two values are the same and these two voltage sources are in parallel. So I'm going to write again 8 volts to the second power over R2, which is equal 4 kilo ohms. This is equal 8 to the second power divided by 4 exponent 3. This is equal 16 milliwatts. Okay, so this is my power at resistor R2. Next, I'm supposed to find total power. P total we can find by using formula I total times voltage source, for example. Okay, so this is one of the formulas. So I total is equal 6 milliamps times voltage source, which is equal 8 volts. Okay, so 6 milliamps times 8 volts is equal 48 milliwatts. Okay. For those of you who still have problems with the calculator, I'm going to show how to enter these numbers into the calculator. So I have 6 exponent 3 negative times 8 is equal 48 milliwatts. Now we can find and at the same time verify our answer by simply adding power 1 and power 2, because the sum of the powers in the circuit will give me the total power. So if P total is equal P1 plus P2. This is equal 32 milliwatts plus 16 milliwatts. This is equal 48 milliwatts. Okay, so as you can see, these two answers are the same, and this is the end of the problem. Okay, so as you can see, all our answers are correct, and we can say that the problem is finished.